In this follow-up problem, part B, we want to figure out how fast must the camera angle of elevation change at that instant to keep the rocket in its sights. So angle of elevation is from the ground up, located where the camera is. So we're wondering, this angle here, how fast is it changing? So now I want to know, well, what is d theta dt? Well, the only way to solve for an angle is to use trigonometry. Now, I can use any of the trig ratios that I would like, but it's a good idea to try to use whichever ratio uses as much given information as possible. Whatever your fixed value is, you definitely want to use that because it'll make your derivative much easier to work with. If we want, since we have the adjacent side, we could do cosine is adjacent over hypotenuse, or we could do tangent is opposite over adjacent. We can do it either way, really. These numbers worked out really nice. We all know that related rates usually don't work out nice. So if those weren't nice, pretty answers, if I had to round at any point in time, I don't want to use them because I could have too many rounding issues in the context of the problem. So while for this particular problem, it would be easier to do cosine is adjacent over hypotenuse, I'm actually going to use tangent just because it uses as much given information as possible. And let's just pretend like we never did part A to begin with. And if this was the initial setup and it just asked me about the angle of elevation, I would have never found dH/dt. Okay. So a trig ratio. We're going to say that the tangent of angle theta is equal to the opposite side. Opposite is over here. It's the y, which is a changing value, over the adjacent side, which is the fixed value of 3,000. So I can plug it in right away. I don't need a variable there. Now, you can write this in lots of different ways. I can write this as tangent theta equals 1 over 3,000 y and do the power rule. The easiest thing that I've seen is swing the constant over to the other side. If I multiply this by 3,000 and multiply this by 3,000, it's usually easier to deal with in that particular setup. So I'm going to make this 3,000 tangent of theta is equal to y, which will be a little bit easier to do the derivative of because now I've got the free ride rule, easier to recognize, okay? So the derivative of 3,000 tan theta is going to be, well, let me change color so I know I'm doing a derivative now. This is going to be 3,000 free ride. The derivative of tangent is secant squared. The variable cannot disappear, and then I have to do the derivative of the variable d theta dt. That's my chain rule. And then the other side, the derivative of y, is 1 and then dy dt. Now I know dy dt. I'm looking for d theta dt. The question I have for you is how am I going to figure out the secant squared of theta? Now here's the beautiful thing. You never need to find theta. These trig problems, you never need to find the angle. Secant, little sidebar over here. Secant theta is equal to 1 over cosine theta. Cosine is adjacent over hypotenuse. So this is the hypotenuse over the adjacent. So secant theta, that ratio, the hypotenuse is 5,000. The adjacent is 3,000. I've done my derivative, so I can use any numbers that I want. All right, that reduces down to 5/3. And then I don't have secant theta, I have secant squared theta. So if I square both sides, if I square this and square that, I have magically figured out that secant squared theta is equal to 25 over 9, which is a relatively pretty number, okay? So now back over to where my derivative is in orange, I'm going to write that this is now 3,000 times 25 over 9, and then d theta dt is equal to dy dt. We said that dy dt, I didn't label it on here. Oh, yes, I did. It's down here. dy dt is 880. If I simplify, let's see, 3,000 times 25 divided by 9 is a fraction still, but that fraction in simplest form using a calculator is 25,000 over 3 d theta dt equals 880. And then how do I divide by a fraction? I multiply by its reciprocal. So we're going to get d theta dt is equal to 880 times 3 all over 25,000, which comes out to, let's see, give me 1 second as I type it in my calculator here. It's 0.1056. Exactly. No rounding involved. So you can make that 0.1056. You can make it 0.105. You can make it 0.106. All three of those would be acceptable answers. You can even write it as a fraction in simplest form, 66 over 625, if you wanted to do that on your calculator. Okay, but remember, answers don't have to be in simplest form. They just have to be in one of the formats that we've talked about. Now, units for an angle. We're talking about calculus. And much to our dismay, angles are measured in radians. Okay, we talked about how everything in calc is radians and not degrees. I know it enrages all you physics kids, but that's what it is. So this is radians per second, which we can write rad per second if you want to abbreviate it. But that's radians per second. It's never in degrees. It's always in radians. Okay, so that right there is